It is easy to look at a passing cloud and see a giant, weightless cotton ball. But that white shape is actually holding up millions of pounds of water. It is a massive, floating city. To understand how a city of water gets up there, we have to look closely at the surface of the ocean. Down here, the sun warms the water, giving individual water molecules enough energy to break free from the waves. This process is evaporation. The liquid water transforms into an invisible gas and begins a long migration up into the sky. Water is physically heavier than air, yet this massive upward migration stays suspended in the sky instead of crashing back down to the ground. As our invisible travelers rise, lower pressure allows the air to expand, cooling it quickly. This chill saps the water molecules' energy. They want to turn back into liquid drops, but they need a physical landing pad to attach to. This is where the sky provides some help. Floating all around these water molecules are microscopic pieces of dirt, salt, and ash. These act as tiny seeds for the water to land on, or little chairs for the molecules to sit on. These tiny seeds often come right from the ocean. When waves crash against the shore, they fling microscopic salt particles high into the winds. The Earth itself helps out too. When volcanoes erupt, they launch vast amounts of extremely fine ash miles into the atmosphere. Even forest fires contribute, sending enormous plumes of smoke and soot up into the air. When the chilled water vapor finally bumps into one of these floating particles, it grabs hold. This is condensation. The invisible gas suddenly transforms into a visible liquid water droplet. This means every single pure white cloud droplet in the sky secretly hides a tiny speck of dirt, ash, or salt right at its core. Pristine clouds actually require dirty air to exist. Now we have a liquid water droplet, and gravity is pulling it down. It is technically falling, but a cloud droplet is only about half the width of a human hair. Because it is so unimaginably small, its terminal velocity is a crawl, maybe a few centimeters per second, and it has to fight against an invisible elevator. Warm air constantly rises from the Earth's surface, creating a steady upward breeze. That gentle updraft keeps pushing against the droplet, perfectly balancing out the pull of gravity. From the ground, a cloud looks perfectly still, like a solid object, but its borders are caught in a constant tug-of-war of death and rebirth. Dry air constantly blows through the edges of the cloud, drying up older water droplets and turning them back into invisible gas. At the exact same time, fresh updrafts are building brand new droplets in the center. These millions of newly formed droplets act like microscopic mirrors. They bounce the sunlight around and scatter all colors equally, which our eyes perceive as a brilliant bright white. A cloud is not a permanent thing. It is a temporary, rapidly rebuilding floating city, held aloft entirely by the warm thermal breath of the Earth below. Eventually, this delicate balance breaks. Updrafts keep pumping more and more moisture into the system, and the floating city becomes completely overcrowded. Turbulent winds force the microscopic droplets to crash and swallow each other, merging into larger drops. As they grow densely packed, they block the sunlight, casting a shadow on themselves, which is why rain clouds look dark from the bottom. Finally, the combined droplets become too heavy. They overpower the invisible elevator of the updrafts and plunge right through the cloud's bottom as rain. The travelers fall back to the Earth, splashing into oceans, sinking into the soil, and feeding the rivers. They have completed their massive loop and wait for the sun to warm them again. Looking up at those white shapes, we're seeing a temporary rest stop on an endless journey, a cycle that forever connects the surface of our planet to the sky.